Good evening. My name is Trevor Andrews, and I'm going to do a electric car presentation on the components of the electric car and their functions and how they work. And this is for AE 366 summer class. Here are the electric car topics that we're going to be going over today. It's going to be electric car main components, how the power is transmitted to the wheels, how is the speed adjusted through transmission system, and the 9 main components of the electric cars that we're going to be going over today is the traction battery pack, DC-DC converter, electric motor, power inverter, charge port, onboard charger, controller, thermal systems, cooling, which is it's just going to be cooling the actual engine and motor and everything like that, and the transmission. And first we're going to start off with the traction battery pack, and as you can see from the image, the traction battery pack is at the bottom of the module of the car itself, and it lays there, and the batteries there are actually in the passenger seat, or below the passenger seat, below the driver's seat, and below the back seats as well. And the traction battery pack is a rechargeable battery used to power the electric motors. A traction battery is designed to convert the chemical energy stored in the batteries to electricity to power the electric motors that propel the vehicle. Lithium-ion and lithium polymer are the most common battery types in modern electric vehicles. The next thing that we have is the DC-DC converter. The DC-DC converter is an electromechanical device used to convert a DC voltage from one level to another based on circuit requirements. They transfer energy from a source to a load by changing their voltage levels. It can choose the voltage variation of the devices and control the power flow in the electric vehicle powertrain. It can also move power in either direction, enabling regenerative braking. The main function is to bridge the gap between the battery voltage and the motor voltage. So all this does is just go from a convert low voltage system to a higher voltage system. And so the low voltage system would be the battery voltage, even though it has a lot stored up, but the low voltage is that, and then it goes to the motor voltage because it takes a lot more for the motor, a lot more voltage for the motor to actually work. The next thing is the electric motor. The electric car motor works by using electricity from a battery to create a rotating magnetic field in a cylinder called the stator. The magnetic field causes another cylinder called the rotor to turn, which provides mechanical energy to the car's gears and wheels. The electric motor also has 6 subcomponents: stator, rotor, which I've already mentioned, commutator, brushes, axle, and DC powder supply. And the motor itself, it takes energy from there and uses it and propels the wheels. But like it said right there, the difference is that the electric car uses a magnetic field actually to get its power and stuff like that, and rotational power, while a combustion engine uses gas to go into the engine and actually fire pistons, and that's how it propels the combustion gas engines. Here we have the power inverter. The electricity from the battery is direct current, which is DC, but the motor needs alternating current, AC, which changes polarity many times per second. An inverter is also responsible for converting DC into AC before it reaches the motor. The power inverter also varies the amplitude of the AC power, which controls the electric motor and the speed of the vehicle. The inverter flips polarity quickly, around 60 times per second, to keep the rotational force going, which makes the car go forward and backwards. So this inverter takes the power or the voltage from the battery, because the battery can only hold direct current, and changes it because the motor and the transmission need alternating current for it to actually propel the vehicle forward. That's what it has to have. And so it changes. This is the vehicle would not be able to work unless it had this power inverter, which changes from DC to AC. And the polarity is the actual magnetic field that it is talking about, that is in there, that I will later on talk about in the presentation. But it's pretty crazy. The polarity goes 60 times per second within that system, and that system right there, it looks like it's like a in the picture, obviously it looks like it's a some type of computer or something like that, but that's just how it has to look for the mechanism of the inverter to transfer it from DC to AC. It looks like they just took computer parts and put them all together, but it's really crazy how they used all of this technology and electromagnetic technology to make this all happen. And all of this is based off of Tesla. The next thing we have is the charge port. Electric cars, unlike regular cars, must be charged by being plugged into a power supply system, just like an iPhone battery has to be charged. The electric car battery charges work using a process called induction charging. Induction charging is where an electromagnetic field is used to transfer energy between two coils of wire. The charge port in an all-electric car has a 7-pin design with 2 small pins connecting data between the car and charger to determine the maximum current available to the vehicle, and 5 larger pins for the 110 to 250 volt AC power connection, including the ground connection. So the crazy thing is that the power goes in AC, transfers to DC to be stored into the batteries. Then when you need to use the power supply for the batteries to actually make the vehicle go forward, the power inverter transfers it from the batteries from DC to AC. So it's a lot of transferring, but that's just how it has to be for it to be actually able to go forward and backwards. And you can see from the picture right there that the 2 little smaller holes at the top, that's the data holes that I mentioned, that kind of is like tell you your charge level of the vehicle, and the 5 smaller holes is actually where the vehicle is actually charging and getting that AC power. The onboard charger's main function is to perform power conversion. The onboard charger is a device that converts AC power from any AC source into a practical DC form. And this is what I was saying. This is the onboard charger. This is what changes it when you charge it. Then this right here changes it to its DC form to go to the battery, and then the power inverter takes it from the battery DC, then changes to AC and goes to the motor and transmission, stuff like that. The onboard charger gets charged at the charger stations and converts the AC power over to DC, which is stored in the battery itself, which powers the car, which is what I just mentioned. And right there is the Tesla actual model of the onboard charger. It looks like a briefcase. It's kind of crazy, but they do have to make everything very weight dependent, small and compact, because if they don't, the vehicle could be over weight requirements and different things like that. Next we have the controller. The controller in an electric vehicle is the device that controls the flow of electricity from the battery to the electric motor. The controller is considered the brain of the electric vehicle. The controller gets its power from the battery, and it uses this power to control the electric motor. The controller tells the electric motor how much acceleration and speed are needed by the amount of pressure on the pedal. So the controller is basically literally like your brain. Your brain has nerves, and they go throughout your body, and if you want to move your finger, those nerves will contact back to your brain and let you know, and let the brain know, hey, it's going to move this. So the brain tells it to, hey, the nerves to move that specific thing. So all it is the gas pedal is connected to one of these wires right here that goes back to the controller, and as you push on the gas pedal, the controller thus increases the torque and the speed and the acceleration of the actual vehicle. The next thing we have is the thermal system, which is the cooling system in the electric vehicle. This is one of the most important parts of it. I would say the most important part of it is obviously the power inverter, because it changes it for the only way that you can get the power from DC to AC. But the thermal cooling system in an electric vehicle regulates the temperature of the battery pack, power electronic base drive, and motor. The cooling loop circulates a coolant, ethylene glycol, using an electric pump to cool the batteries. electronics, motor, and related systems. The coolant gets hot as it cools the battery and is cooled in a heat exchanger, then recirculated in a closed loop. Just closed loop system is what we've actually worked on a lot in this course. Radiators are used in the cooling loop to release the heat to the ambient. If needed in the winter, the thermal system will convert the battery heat to heat up the cabin of the car, which is, I found that very crazy, that the car itself in the winter has the ability to heat up the inside where you want it to be warm at, which is really awesome. But as you can see on the diagram to your left, this is the basically a diagram of the high voltage cooling system. So it starts out in the reservoir and it goes through the engine pumps. It's got one engine pump and two engine pumps. They're labeled. And it goes there, and it goes to the reservoir, and then it goes to the onboard charger. Okay, it cools that off and everything. Then it goes to DC-DC converter, goes through there, and it goes through the inverter, traction motor, and then through the radiator, which through the radiator is where it goes in hot, and then the radiator just naturally cools it off, and once it gets to that lower temperature, then it transfers it back to the reservoir, and then you have the repeating of the process. Next we have the transmission. An electric car has a single-speed automatic transmission that sends power from the motor to the vehicle's wheels, and this is all based off of Tesla technology, but other electric vehicles are slightly different in different aspects. They can have more than a single speed, which is single speed just means one gear. The single speed transmission operates like a bike, with acceleration felt instantly after motor revolutions per minute increase. Electric vehicles use a simplified drivetrain that includes a single speed transmission rather than a conventional internal combustion drivetrain. Electric vehicles can immediately take input from the driver to start spinning the wheels with direct torque applied. So it's crazy that the single speed in the Tesla, there is one gear shaft, and it actually, as you push the pedal, it immediately accelerates. It's like if you got ever on an electric bike, if you start the electric bike, it has no buildup. It starts out at that speed. It does the buildup to it a little bit, but there's no shifting gears, nothing like that. And this is what that means. There's no shifting gears with the Tesla electric car transmission. Next, we have the other main idea that we had and that we were going to discuss is how the power is transmitted to the wheels in an electric vehicle. Electric vehicles obviously don't have combustion engines like gas-powered cars, so electric vehicles use magnetism to power their vehicles. They use electromagnets, which is a core of metal coiled by electrical wire to reverse the polarity of the magnets to reverse at extremely high rate continuously using an inverter. The inverter draws DC from the batteries and switches it to AC at around 60 times per second, as mentioned before. The inverter sends the AC power to the transmission or single-speed gearbox, which connects the motor and wheels with one gear rotation. This single-speed gearbox, also known as a transmission, does not shift gears and just stays at one gear, but increases and / decreases speed depending on the action of the driver. Like I said before, it's a north and south magnet, and it just spins with the electromagnetic wire and the electromagnetics to spin at 60 times per second. The next thing that we have is how is the speed adjusted transmission system. Some of my other slides may have answered this question already, but I'm going to go into more details. For starters, the single speed transmission means no shift in gears, which means a steady speed according to the pressure on the gas pedal, which is quote unquote gas pedal. It's not really gas. They also use a reduction gear mechanism. A reduction gear mechanism is a type of system within the transmission that can change the gear ratio of an electric car according to the driving speed and torque demand. This can help improve the efficiency and performance of an electric motor by operating it at optimal range. And all this is just the power going into the transmission. It changes it and goes into that optimal range and gives it the torque and speed. And any feedback and questions, just let me know in the comments below or anything like that. This is my electric car presentation, and this is actually a diagram that shows you where all these pieces are at inside of the electric car. And to close it out, here's all my references. A lot of them from Tesla, a lot of them from Universal Electric Vehicle and different things like that. But thank you.